Hello engineers, welcome back. In the previous video, we learned about dynamic memory management in C++ and we got a very good foundation to many things in C++ and I think now we have a good grasp on the language. So now it's time that we get into actual DSA and today we are going to start with arrays as the data structure. Okay, let's get started. So in this video, we're going to look at arrays. We'll see what arrays are, and we're going to see what operations we can perform on the arrays, and we'll see how to insert, read, update, delete, and iterate through the array. Okay, let's get started. So arrays are pretty straightforward. So arrays are a couple of things. Arrays are having contiguous memory. We'll understand this with an example. And arrays contain data of same type. These are a couple of things to keep in mind. Contiguous memory and data of same type. So let's see an example. Let's say I have 100 students and I want to store the marks of these 100 students. So I can say in a traditional way, I could say marks student 1 underscore marks equal to 90 and s2 underscore marks equal to 92 and so on up to s100 underscore marks equal to, let's say, 87. So we can create 100 variables like this of type integer, and then if we want to modify any of these, we'll just use the variable name. But this is pretty inefficient, right? We cannot possibly manage so many variables in our code very efficiently. So it's very tedious and cumbersome to write code like this. So we can take the help of arrays. So how can we achieve the same thing with arrays? We can simply say we'll still store integers and we can store them in something called a marks array. And since we have 100 students, we'll ask for 100 integer memory blocks. Okay. So what happens when we request like this? So inside the RAM, let's say this is my RAM, I'm getting 100 blocks. 1, 2, 3, 4 up to 100. So each block is of 4 bytes. 4 bytes because it is integer. And 4 bytes here, 4 bytes here, and so on, 4 bytes up to the end. So how many in total? 4 into 100, 400 bytes. 400 bytes of memory is what we have requested, and we got them. Okay, so just by using one variable called marks, we are able to do the work of 100 variables. So that is much more easier to manage and very efficient. And because we are using one variable, we can do so many other things with it. Like we wouldn't be able to do with 100 variables individually. So we can see all that uh, with arrays. Okay. So this is how you ask for memory in the arrays. Okay. And a couple of things to remember here. Like I said in the beginning, it is contiguous memory. So you see this block of array, this is continuous. So this 4 bytes is followed by the next 4 bytes and it's followed by the next 4 bytes. We don't get memory like this. One int here, and somehow there is a connection, another int here, somehow there's a connection, another int here, somehow there's a connection. No, this does not happen. We only get continuous memory in arrays. Okay. And another point is data of same type. So when we say int marks 100, every block of memory will hold integers only. I can put 4 here, but I cannot put the character A. This is wrong. I can store integers only, 0, 2, 100, and things like that. And if I want to put, uh, let's say, the word apple in it, I can create a character array. I can ask for character, fruit of 5, and I will get 5 blocks. Oops. I will get 5 blocks, and each block will be of 1 byte and a total of 5 bytes, because one character needs only 1 byte. So here I can put A, here I can put P, P, L, E. So this is character array. Similarly, I can create float array and things like that. And here also we are getting continuous memory, sequential block of memory. Okay. So this is how you create an array. Let's see how we can perform some operations on an array. Let's start with insert. So how do we put data into the array? So there are a couple of ways. First way is initialization. So how does this look like? So I can say int marks of say 5 students, and I can simply do like this: 92, 90, 87, 93, and let's say 72. I can do like this. So what is happening here? I'm getting 5 memory blocks, 1, 2, 3, 4, and 5, and they are of type integer. And this left portion is taking care of memory allocation, and this right portion is taking care of initializing. So 92 goes here, 90 goes in the next block, 87 goes in the next block, 93 goes in the block after that, and then 72, and we are done. So this is how we can put data into the array. Okay. What is the second method? Second method is by using index. So arrays come with a feature called indexing. So when we create an array like this of 5 integers, it comes with something called indexes. So they are nothing but numbers which can be used to access those memory blocks. So because these are in RAM and everything has a memory address, we don't want to use the hexadecimal values every time we want to access some memory element. So instead, arrays give us a neat and easy way to access the elements. So we can use index. So if we are using any index value, we can directly insert. So let's see how this works. So let's say I have int marks of 5, but this time I have not initialized them, and I got my memory block, but now I want to put data into it. So how do I do that? I can do like this. So I can say marks of 0 is 92, marks of 1 is 90, and I can do marks of 2 is 87, and 3 93, and 4 72. Okay, I can do like this. So you will notice that the numbering starts from 0 and not from 1. So this is something to remember. So as you practice it, you will get used to it. But you should always remember that the numbering of the index starts from 0. Okay, so the first block is 0, the second block is 1, and so on. Okay, so I have achieved the same initialization using indexing. So this is how we can put data into the array. So if we know the index, so we can directly use the assignment operator to use to put data into it. Okay, so this is how these are the two ways to put data into the array. Okay, now let's see how we can read from the array. So for reading, we will also make use of the indexes. we will also make use of the indexes. Since now we know that this little guy will take care of assignment, we can also use this notation to read data. So if I want to print the first element, how will I print? I can say cout marks of 0. Okay, so what will happen here? The marks is the name of the array, and this square bracket will indicate that I am trying to use the index notation. And what is the index number? It is 0. So it will go here to my array, and it will check what is available at the 0th index, and this 0 has the number 92, so 92 will be printed. Okay, in the same way I can print marks of 1, marks of 2, and so on. So that's how we can read data from an array. Okay, let's see how we can update data into an array. So far we have seen initialization, and let's say this is my initialization. Now I want to change the value. Again, we will make use of index. So if I want to change the value of the last element, I can again make use of the index. So marks of 4, now I want to change it to, let's say, 85. So here in this step the value is 72. Now again in this step what will happen? Marks is a variable of the array, and we are using square bracket, so the notation is using the index. So what is the index? Number 4, and it will go here and see where is number 4, and number 4 is having 72. Now 72 will get replaced by 85. So that's how updations happen in an array. Okay, quite simple. Okay, now let's say we want to delete. Something. So in an array there are couple of things to remember. First thing is deleting at the end, and second thing is deleting in between. So if this is my array 1 2 3 4 5, if I want to delete at the end, I can simply remove this. So we can simply remove the element. So what does it mean to remove the element? We are setting it to 0. So how do we set it to 0? We can simply say array of 4 is 0. Why 4? Because the index is 4. 0 1 2 3 4. Okay. So why 0? So for this we need to understand the default behavior of arrays. So let's say I want to say array of 3, but I have only initialized 2 values. So what will happen here? I get 3 blocks, index 0 1 2, and I have put 1 and 2 in the first 2 blocks. But what happens to the third block? This is still allocated to this variable, right? This is still allocated. So by default C++ puts 0 in it. Okay, so if there is nothing initialized, C++ puts 0 in it. Okay, if nothing is initialized, so this is partial initialization. We have initialized couple of blocks, but we have not uh, initialized the array completely. But if we have done like this, I have simply said int array of 3 and I have not initialized, and if I try to access a of 0, what do you expect? We cannot expect 0. In this case it is garbage value. This is similar to how we do int data type. If I do int a and I try to print cout a, what will happen? We will get garbage value. But once you have initialized an array partially, it will automatically fill the remaining values with 0. So that is the default behavior of C++. Okay, So that's why when we say delete an element in an array, we are not exactly removing it from memory, we are simply assigning it to 0. And when we say 0, we will simply treat it as removed. Okay, it's not exactly removal, but it's something to work with. Okay, because we still have that memory reserved for us, because we can again put back stuff in it. Again, I can say array of 4 is 20 and it will work. Okay, and if I want to delete something in between, I can, if let's say I want to delete this one, a of 2 is 0, but in this case I can do a couple of things. Either I will put 0 here, either I will put 0 here, or I will left shift everything. I will left shift everything. What do I mean? Let's say I have 1 2 3 4 5, right? And if I want to remove the middle element, I don't want this at all. I don't want the number 3 appearing anywhere, and I want my array to be rearranged like this: 1 2 4 5, 1 2 4 5. And I'm okay with the last guy having 0 because that is the default behavior. Let the last guy have 0, but I don't want this middle guy. In that case, what I'm doing, I'm left shifting. So there was 3 here. Now I will take the rightmost element, immediate right element to it, and I will put it here. And I will left shift the other element, I will put it here until I reach the end. And once I reach the end, the last guy will automatically be reserved for with a 0, because that is a default behavior. So this way I have removed another element. Now let's say I want to remove the number 4. I will do the same thing. I will left shift number 5 here, and I will left shift this guy here. So what will happen? It becomes 1 2 5 0 0. Okay, so this is left shifting. So if I want to remove the first element, I will remove like this. What does it mean to remove? I will simply left shift. I will copy this value into the previous array block, and I will repeat the operation for everything else. So now this becomes 2500. Okay, and one more block is a new block which is having 0. Okay, that way we can remove elements from an array. Okay, so we have covered inserting, read, write, delete. So inserting, read, update, and delete. Let's see how we can iterate. So what does iterate mean? So if I want to print if I want to print the marks of these 5 students, how will I print? I can do like this: marks of 0, and I will repeat it for marks of 1. I will repeat it for marks of 2, marks of 3, and marks of 4. This is one way of printing, but we cannot do like this for thousands of elements, right? Thousands of elements. So we will take the help of our loops. We studied loops. We will take the help of one of the loops. So I can make use of a for loop. How does it look? For int I equal to 0, I less than 4, sorry 5, because there are 5 elements, and I plus plus, and I can simply do cout of marks of I. Okay, so what is happening here? Let's break it down. So first we are taking an element I and putting the value of 0. So I is here, the value of I is 0. Next we put in a condition. Condition is I less than 5. So as long as I less than 5, this loop will repeat. And what is 5? 5 is the size of my array. 5 is the size of my array. And then after performing each loop, each iteration, we are incrementing the I by 1. Okay, that is the third one. So I plus plus, and inside we can do bunch of operations. So in this case we are simply printing out the marks. So here we are using the concept of index notation. So marks of I, what is the value of I is 0, so this becomes marks of 0. Marks of 0. So what is marks of 0? Marks of 0 is 92. So 92 will get printed, and there is nothing else to do inside this loop. So the compiler goes here, and what does it do? It does the third thing, increment I by 1. So now I is no longer 0, I has become 1, and the loop is repeating. It goes here, we're checking for marks of 1. What is marks of 1? Marks of 1 is 90. So 90 gets printed. So let's say this is the console. So far we have printed 92. Now 90 gets printed and I is incremented to 2. Next we are going to marks of 2. Marks of 2 is 87. So 87 gets printed and I is incremented to 3. And this repeats. So next one is 93, I becomes 4. Next one is 72 and I becomes 5. So at this point this condition fails. I is no longer less than 5. It has become equal to 5. That's why this loop is failed, and we have everything in our output. We have successfully uh, went to each element of an array and we have printed it. So this is called iterating an array. This is called iterating an array. So it is like looking into each and every element of an array. So that's why it's called iterating. Okay. This is not the only way to do it. I can do uh, reverse iteration also. For example, I can do like this. For I equal to 4, I greater than equal to 0, I plus plus, cout marks of I. So what is happening here? This is reverse iteration. So let's trace it. This is the value of I. This is the console output. Let's see. So what is the value of 4? Value of I. What is the value of I? I is 4. And inside what are we accessing? Marks of I. So what is marks of 4? Marks of 4 is 72. And here instead of doing I plus plus, I need to do I minus minus, because I'm doing it in reverse. So now the value of I becomes 3, and we go inside again, marks of I, and marks of 3 is 93, 93, and I now becomes 2. Marks of 2 is 87 and I becomes 1. Marks of 1 is 90 and I becomes 0. And marks of 0 is 92 and I becomes minus 1. And at this time, this condition is no longer valid. We said I should be greater than or equal to 0. That's why we come out of the loop and we have successfully reverse printed the array. So we have uh, successfully iterated the over the array in reverse. Okay. So this is useful when we want to print, let's say, reversing a string or reversing a number, palindrome, things like that. Okay. We can do a bunch of things like this. So this is about iteration. So it's a little introductory to arrays. So I try to keep it a little quicker and faster, so that we can uh, go away from theory and start writing code. So let's look at all this in code now. Okay, let's get started. Let's go to VS Code, and where are we? So let's create a new folder for our arrays, and let's create a file. Let's say intro.cpp. So we are doing intro to arrays. So let's quickly create our template. Okay, we are good. So let's see. So how do we first create an array? As we discussed, it's simple. So you simply ask for a of 5 and we get 5 bytes of 5 integer blocks of memory. 5 into 4, 20 bytes. And how do we initialize? How do we put data? Initialize array. So let's take another array, p of 5, and I want to put data in it. I want to put, let's say, 1, 2, 3, 4, 5. So this is initialize. The next thing what we saw, insert into array. So for this, let's take another array, and we already have an array. We can make use of that. So I can put a of 0 as 1, and I can repeat it. A of 1 as 2, a of 2 as 3, a of 3 as 4, and a of 5 as 5. So this is initialization and inserting. So in B array, we have initialized it directly. In A array, we have inserted it using the index notation. Okay. Now let's try to access elements. So how do we do that? We use cout, and let's call a of 0 inline, and let's also print a of 1. Okay. So let's see how this works so far. I hope there are no syntax issues. Array index 5 is passed the end of array which contains 5. Oh, I made a mistake here. This is index 4. So this is very important. Let me also cover this point because this came up. So now I have tried to access an element that is not there. So far we have seen examples where we are inbound. So now I have this is my array. There are 3 indexes, 0, 1, 2. So if I want to access the fourth index like this, a of 4, what happens? So there is no a of 4. So the compiler tries to go to a and check for the number of indexes available. It is only finding 0, 1, 2, but I'm asking for fourth. So it is not unable to find. So this is called array out of bound. Array out of bound. So far we have been inbound in the boundary of the array. So now we have come out of the boundary and this is not allowed. So a compiler is throwing us an error. Okay. So let's run it again. And now we see 1 and 2. So this is the cout printing of a of 0 and a of 1. So we are using index notation on array variable a of 0 is 1 and a of 1 is 2. Okay. So what else? Update array. So just like how we have inserted, let's try to update. So I can now change the value of a of 0 to, let's say, 10, and a of 1 to 20. Now it is updated. So if I want to print it again, I can do it. Now the value will change to 10 and 20. Okay, previously it was 1 and 2, 10 and 20. So I also spoke about garbage values, right? Let's see how that looks like. So I have an array here, but I have not initialized them. If I want to access those elements, what will happen here? There should be garbage values inside. Let's see. See, all this is garbage stuff. And then once we have initialized, we are able to put our data into it. I also spoke that there is a default behavior that the remaining elements will be 0. So let's see that also. So if I want to put, where do I put it? I have initialized all the elements. Let's take a new array, no problem. Let's take a new array. Default to 0. Let's say we want to see default to 0. I will say int c of 5, but I will only give 1 comma 2. I will not initialize the remaining elements. This is partial initialization. What is this? Partial initialization. So what is happening here? If I want to access the elements C of 0 n line, it works. And if I want to do C of 1, it works because I've initialized them. But what if I want to do C of 2? Let's see what happens now. You see, there is 1, 2, and then there is 0. If I put C of 3 and 4, they will also be 0. So the remaining elements are all 0. See, this is the default behavior. Okay, next. So how do we remove? How do we remove? So I told there are two methods. One is setting it to 0, which is just like this. If we don't put anything, it is already setting it to 0. I can simply say, if I want to remove the last element, which is at index 1, I can simply say C of 1 equal to 0. And that's it. That is one way of doing it. If I totally want to remove it, if I totally want to remove it from the beginning, let's say if I want to remove the first element, what can I do? I will left shift the remaining elements. Okay, left shift the remaining elements. So how can I do that? I will need to make use of loop. So let's iterate over the array. Let's create a loop. Let's say I want to remove the first element. So index I equal to 0, I less than 5, and I plus plus. So what do I need to do? I need to left shift everything. So whatever was in um, index 1, I need it in index 0. So what can I do? C of I plus 1, which is index 1, equal to, sorry, C of I will become C of I plus 1. So let's trace this. What is happening here? So I is 0. So C of 0 will now become C of I plus 1. I plus 1 is 0 plus 1 is 1. C of 1 is holding the value 2, and 2 is left shifted to this position, and now this is gone. Okay, that way we can left shift it. Okay, and the remaining values were already 0 anyway, so they just get filled with 0. Okay, now let's print it. Now let's print this array. So we can use the same loop, and instead of operating on it, we can simply print it. So just to separate our console, let's add a quote here after delete. Deleting first element. Okay, let's see. Oh, sorry, I need to use double quote. Let's see. So where are we? After deleting first element, everything became 0. So we did some mistake. Let's see. I equal to 0, I less than 5, I plus plus, C of I, C of 0 will become C of 1, correct? And then I becomes 1, and there is 0, 0, 0. I equal to 0, I less than 5, C of I. So what is the mistake here? C of I equal to C of I plus 1. C of I plus 1, I is 1, C of 1. Oh, I have put it to 0 here. That's why. So let's remove this statement. Let's run it again. And here, see 0, 0, 0. Okay, so the last element, it has initialized to garbage value. No problem, it is still removed. So we are okay. So at least we have left shifted everything else. Okay, so that's how we can delete items from an array. Okay, so I think that covers all the topics that we wanted to discuss here. So we saw in this video what are arrays, and we saw how to insert an array, how to read from an array, how to update an element, how to delete an element, and how to iterate an element. Okay, so this is a quick introduction to arrays. So if you're already familiar with arrays, this is like a refresher. If you are not, so please practice arrays. We're going to use it a lot. And if you have any questions, please don't hesitate to ask me. And in the next video, we will continue to learn about arrays. Okay, thank you so much for watching. Please don't forget to leave a like. Please leave a comment if you have any question, and if you have any thoughts on the video, and do share it with your friends. Do bookmark the playlist, and I will see you in the next one. Thank you. Cheers.